In this video, I will show you how to solve a quadratic equation using a Viète method, which is quite a bit different than the standard method we all love. So let's get started. This method doesn't require much more background knowledge than the distributive property. To review that, let's suppose that I have x minus 3 in one bracket multiplied by x minus 4 in a different bracket. So how to expand these brackets? We simply multiply each element from the first bracket with every element from the second bracket. That means that we have x multiplied by x and we get x squared. X multiplied by negative 4 is minus 4x. Minus 3 multiplied by x is minus 3x. And minus 3 multiplied by negative 4 is positive 12. So this is then equal to x squared minus 7x plus 12. As you can see, this negative 7 comes from negative 3 plus negative 4. The 12 comes from negative 3 multiplied by negative 4. So in general case, this would be x minus alpha multiplied by x minus beta. This is equal to x squared minus beta x minus alpha x and plus alpha beta. This is then equal to x squared minus alpha plus beta in parentheses, x as common, and plus alpha beta. So what happens when we have something like 3 minus u in one bracket multiplied by 3 plus u in the second bracket? We have 9 as 3 times 3 is equal to 9. We have 3 times u as 3u. We have negative u multiplied by 3 as minus 3u. And we have negative u multiplied by u, which is negative u squared. These two can cancel out and we just have 9 minus u squared. It turns out that this is an interesting way to solving quadratic equations. So now I know that I can write x squared minus 7x plus 12 in a different form. This is x minus 3 multiplied by x minus 4. When we talk about a quadratic equation, often the standard form of a quadratic equation is something like this. Term on the left side is equal to 0. So x squared minus 7x plus 12 is equal to 0. You want to know at which points this is true. The nice thing which has happened is that we can write this quadratic term as a product of two terms. So if I want to know when exactly is going to be equal to 0, I can ask exactly when is x minus 3 multiplied by x minus 4 going to be equal to 0. This is a product of two numbers. If you multiply two numbers together and get 0, that happens when at least one of those two numbers is equal to 0. That is actually called the zero product property. And that means that x minus 3 is equal to 0 or x minus 4 is equal to 0, which leads us to x being equal to 3 or x being equal to 4. And this tells me that the two solutions of the quadratic equation x squared minus 7x plus 12 is equal to 0 are x equal to 3 and x equal to 4. Those are the only values of x which, if I put them into x squared minus 7x plus 12, give a quantity which is equal to 0. The conclusion here is that if I am trying to solve a quadratic equation, what I need to do is find this factoring and then I can read the answers. The answers are whichever numbers that make the 0. In this case, those are numbers 3 and 4. So this is the method of factoring for solving the quadratic equations. The method of factoring is to try to take the quadratic and write it as a product. So let's now try using this factoring to solve the next problem. X squared minus 14x plus 24 is equal to 0. When we are working this out by factoring, we need to write x squared minus 14x plus 24 in the form of x minus alpha multiplied by x minus beta, where alpha and beta are the numbers which are the solutions. In some books you will see plus signs here instead of minus. I am using minus sign on purpose because that is going to be more convenient and it is going to show us something interesting that is happening in the background. Now if you think of what happens when you expand the brackets, the problem becomes x squared minus 14x plus 24, it is equal to x squared minus alpha plus beta multiplied by x and plus alpha beta. So we need to find these two numbers, alpha and beta, so that they add to 14 and they multiply to 24. So if I can find two numbers, alpha and beta, such that x squared is paired with x squared minus alpha plus beta x is paired with minus 14x, minus and minus, x and x, alpha plus beta is 14, so alpha plus beta is 14. Alpha multiplied by beta pairs with 24, so alpha multiplied by beta is 24. This is a system of two equations with two unknowns which we have to solve. Then these two numbers are going to be the solutions of this quadratic equation, and they are all the solutions. Then those two numbers, alpha and beta, are going to be the solutions of this quadratic equation. And they are the only solutions. All the solutions. Now the problem becomes to find these two numbers. Notice that there is this if here, which is a very important word, because I don't actually know if these two numbers exist. The usual method by which people find these two numbers from this system of equations is to guess and check. That is what I have learned when I went to school. It is also something that I hated with passion. So it turns out that there is a much better way to approach this problem. We are used to think of this as a factoring method. So we always try to factor the product, and we are thinking of all these different ways to factorize 24 and then find ways to find two factors of 24 that multiply to 24 and add up to 14. So 24 we can factor out as 4 multiplied by 6, also as 3 multiplied by 8, and 12 multiplied by 2. And there is of course 24 multiplied by 1. The trick is to actually start from the sum, this first equation in the system, not the second one which is related to a product. Two numbers have a sum of 14 exactly when their average is 7. And two numbers have an average of 7 exactly when those two numbers are 7 minus a little bit and 7 plus the same bit. So I am talking about alpha plus beta being equal to 14, and we can observe that as 7 minus u, which is some distance away from 7, 7 being the half of 14. And we can observe the second number as 7 plus the same bit u. They are equidistant from 7. This is going to be the number alpha, and this is going to be the number beta. So we have alpha plus beta to be equal to 14 and alpha multiplied by beta to be equal to 24. We are going to write alpha as 7 minus u, and we are going to write beta as 7 plus u. And at this point, I just need to find a u, so that 7 minus u and 7 plus u give the product. So alpha multiplied by beta is 24, and that is 7 minus u multiplied by 7 plus u. And this product is the form which I have shown you at the beginning of this video. It is 49 minus u squared. So 49 minus u squared is equal to 24, which means that 49 minus 24 is equal to u squared, and then u squared is equal to 25. Well, this means that u is equal to 5 or u is equal to negative 5. And now, since the u exists, I can get the two numbers alpha and beta with the sum of 14 and the product of 24. Just put 5 into alpha, which was 7 minus u. So this is 7 minus 5, and that is equal to 2. We are going to put the same u in this one. So we have 7 plus 5, which is 12. Now, regarding u is equal to negative 5, what happens now? I don't actually need the other direction in order to finish. I just need to know that there is a logical connection with equivalence so that I can get from u is equal to 5 all the way up to 7 minus u multiplied by 7 plus u. So for u is equal to negative 5, this logical connection still exists. And then I would get that alpha is equal to 7 minus negative 5, which is equal to 12, and beta is 7 plus negative 5, which is equal to 2. These are the two numbers that work. Those are the same pair. So I am just showing you that whether you write the plus or the minus, that would not make any difference. Now that I have found these two numbers, alpha and beta, the if part is completed and I get to then. So then, and they are all the solutions. I like this technique because you can use it without any guessing. Let's now try a different equation. We have x squared minus 8x plus 13 to be equal to 0. We are going to write x squared minus 8x plus 13 in the form x minus alpha multiplied by x minus beta. We know that this is equal to x squared minus alpha plus beta x and plus alpha multiplied by beta. So if we can find alpha and beta such that alpha plus beta is equal to 8 and alpha multiplied by beta is equal to 13, then they are all the solutions. Thirteen is a prime number, and that means that except 1 and 13, it is not obvious which other two numbers give the product of 13. And if we try the pair 1 and 13 as alpha and beta, we get that their sum is equal to 14, which is different than 8. So let's start from the sum again. Alpha plus beta is equal to 8. The question is, what would give me a sum of 8? And the average of 4 will give me the sum of 8. So I need to find u such that 4 minus u and 4 plus u give the product. So alpha is equal to 4 minus u and beta is equal to 4 plus u. 13 is equal to alpha multiplied by beta, and this is 4 minus u multiplied by 4 plus u. This is equal to 16 minus u squared, and then we get that u squared is equal to 3, which means that u is equal to a square root of 3, or a square root of -3, which is going to give us the same pair. So there is no need to go through the both possibilities. Well, then alpha is equal to 4 minus u, which is 4 minus the square root of 3, and beta is equal to 4 plus u, which is 4 plus the square root of 3. And sometimes we write this answer in more compact way, as 4 plus or minus a square root of 3. In this case, as the answers are not integers, it would be very hard to guess them. This shows that this method can solve any quadratic equation, even when the solutions are not integers or rational numbers, that you can easily guess. This method works for all kinds of quadratic equations. I am going to solve more problems using this technique just to show how general it is. So let's observe the equation x squared minus 8x plus 18 equal to 0. We are going to write x squared minus 8x plus 18 in the form of x minus alpha multiplied by x minus beta. And we know that this is equal to x squared minus alpha plus beta x and plus alpha multiplied by beta. If we can find alpha and beta, such that alpha plus beta gives us 8 and alpha multiplied by beta gives us 18, then they are all the solutions. So to get the sum of 8, all I need is to find the two numbers which are on the equal distance from the average. We need a number u such that alpha is equal to 4 minus u and beta is equal to 4 plus u. So then 18 is going to be alpha multiplied by beta, which is the second equation of this system, and we are going to write it as 4 minus u multiplied by 4 plus u. This is 16 minus u squared, and then we get that u squared is equal to -2. Well, this just means that u is going to be I multiplied by a square root of 2. So as you can see, this method works even in those cases when complex numbers appear. And finally, we get our two numbers. Alpha is going to be 4 minus u, which is 4 minus the square root of 2 multiplied by u, and beta is going to be 4 plus u, which is 4 plus the square root of 2 multiplied by I. Now, it is obvious that this method can be used to solve any quadratic equation, and you don't need the quadratic formula anymore. With these examples, the only issue you might have is that you can say that we had the minus and plus signs in the quadratic equation at the right place. So let's try something else. Let's try the equation x squared plus 6x minus 4 equal to 0. We are going to write x squared plus 6x minus 4 in the form of x minus alpha multiplied by x minus beta. And this is x squared minus alpha plus beta x and plus alpha multiplied by beta. If we can find alpha and beta, such that alpha plus beta is equal to -6 and alpha multiplied by beta is -4, then they are all the solutions. So alpha plus beta is equal to -6. And I just need u such that -6/2 minus u and -6/2 plus u give the product. So this is going to be alpha and this is going to be beta. So alpha is equal to -3 minus u and beta is equal to -3 plus u. From the second equation we then get that -4 is equal to alpha multiplied by beta, which is -3 minus u, and multiplied by -3 plus u. This is equal to 9 minus u squared. And then you get that -4 minus 9 is -u squared, and u squared is just equal to 13, which means that u is equal to a square root of 13. Well, this means that alpha is equal to -3 minus u, which is -3 minus the square root of 13, and beta is equal to -3 plus u, which is -3 plus the square root of 13. And those are all the solutions. So far, we always had the sum to be an even number, so we have never encountered any problems with dividing it by 2. What happens when that sum is an odd number? So let's look at the equation x squared minus x minus 1 is equal to 0. We are going to write x squared minus x minus 1 in the form of x minus alpha multiplied by x minus beta. This is x squared minus alpha plus beta x and plus alpha multiplied by beta. If we can find alpha and beta such that alpha plus beta is equal to 1 and alpha times beta is equal to -1, then they are all the solutions. Since alpha plus beta is equal to 1, I need to find u such that alpha is equal to 1/2 minus u and beta is equal to 1/2 plus u. And these two numbers give the product. So -1 is going to be alpha multiplied by beta from the second equation, and that is 1/2 minus u multiplied by 1/2 plus u. This is 1/4 minus u squared. So this is -1 minus 1/4 equal to minus u squared, and that means that u squared is equal to 5/4, which means that u is equal to a square root of 5/2. And then alpha is equal to 1/2 minus u, which is equal to 1/2 minus the square root of 5/2, which is 1 minus a square root of 5 divided by 2. Beta is equal to 1/2 plus u, and that is 1/2 plus the square root of 5 divided by 2, and that is 1 plus the square root of 5 divided by 2. Let's now do one complicated equation when at the front we don't have just x squared, but 2x squared. So the equation is 2x squared minus 4x minus 5 is equal to 0. We can divide the entire equation with 2, and then it becomes x squared minus 2x minus 5/2 is equal to 0. So x squared minus 2x minus 5/2 we are going to write in the form of x minus alpha multiplied by x minus beta, which is x squared minus alpha plus beta x and plus alpha multiplied by beta. If I can find alpha and beta such that alpha plus beta is equal to 2, and alpha multiplied by beta is equal to 5/2 negative, then they are all the solutions. So I need u such that alpha is equal to 1 minus u and beta is equal to 1 plus u, and they give the product. So minus 5 over 2 is equal to alpha multiplied by beta, and that is 1 minus u multiplied by 1 plus u. This is 1 minus u squared. So u squared is equal to 1 plus 5/2, and that is 7 over 2. So u is going to be a square root of 7 divided by a square root of 2. So now alpha is equal to 1 minus u, which is 1 minus a square root of 7 divided by a square root of 2. We can rationalize the denominator to make it look pretty, and then we get 1 minus the square root of 14 divided by 2. Beta is equal to 1 plus u, and that is 1 plus the square root of 7 divided by the square root of 2, and that is equal to 1 plus the square root of 14 divided by 2. At this point, we have seen that this method can solve any quadratic equation, because this method will always come down to taking the square root at the end. Let's now use this method to derive the quadratic formula. Let's first solve the equation x squared plus bx plus c equal to 0. We are going to write x squared plus bx plus c in the form x minus alpha multiplied by x minus beta, which is x squared minus alpha plus beta x and plus alpha multiplied by beta. If we can find alpha and beta such that alpha plus beta is equal to negative b, and alpha multiplied by beta is equal to c, then they are all the solutions. Just as before, in order to get the sum of negative b, we just need to get an average, which is negative b half, to get that. So we need u such that alpha is equal to negative b over 2 minus u, and beta is equal to negative b over 2 plus u. And they are going to give us the product. From the second equation, c is equal to alpha multiplied by beta, which is negative b half minus u multiplied by negative b half plus u. This is equal to negative b half squared minus u squared, which is b squared over 4 minus u squared. So u squared is c minus negative c plus b squared divided by 4. U is then going to be equal to a square root of b squared divided by 4 minus c. And if you choose negative square root, that is also okay. That will give you a solution set too, but it will be the same solution set. The important thing is that this square root of b squared over 4 minus c always exists. No matter what b and c are, I can always take the square root of any number, and then the solution to the quadratic equations are alpha, which is negative b half, minus the square root of b squared divided by 4 minus c, and beta, which is negative b half, plus the square root of b squared divided by 4 minus c. Now the solution, negative b half plus or minus the square root of b squared divided by 4 minus c, doesn't look like the quadratic formula we are all used to. It is actually equivalent to it. Let's now get the quadratic formula which we know. So our equation now is ax squared plus bx plus c is equal to 0. If a is equal to 0, then bx plus c is equal to 0, and that means that x is equal to negative c over b. This is a linear equation, which means nothing special. Now let's observe what happens with a which is different than 0. In this case, we have a real quadratic equation. So we are going to take the formula ax squared plus bx plus c equal to 0, and we are going to divide it by a. Since a is different than 0, we can divide by it. And we get an equivalent formula, which is x squared plus b over ax plus c over a, which is equal to 0. In our previous example, we had an equation x squared plus bx plus c equal to 0. So capital B is going to be b over a, and capital C is going to be lowercase c over a. The solutions are minus b half plus or minus the square root of b squared divided by 4 minus c. This is going to be negative b over 2a plus or minus the square root of b squared divided by 4a squared minus c over a. This is equal to negative b over 2a plus or minus the square root of b squared minus 4ac divided by 4a squared. And this is going to be negative b over 2a plus or minus the square root of b squared minus 4ac. And this is going to be negative b over 2a plus or minus the square root of b squared minus 4ac divided by 2 multiplied by absolute value of a. Since we have here plus or minus, they are going to work with an absolute value such that we can remove the absolute value entirely. And that will not affect our solution. So this is equal to negative b over 2a plus or minus square root of b squared minus 4ac divided by 2a. We can rewrite this as minus b plus or minus the square root of b squared minus 4ac divided by 2a, which is a quadratic formula we are all used to seeing. Although we got the quadratic formula at the end of this video, I have to say that the purpose of this video was not to derive the quadratic formula so that you can memorize it. I wanted to show you this method because with it you can replace the parts which were done by the annoying guesswork with an actual mathematical method which is based on reason rather than luck. You can also use this method to reason every step which you make in solving the quadratic equation. Even if you forget the quadratic formula, you can use this method to solve the given problem. Even if you don't start with an equation which looks like x squared plus bx plus c is equal to 0, but it has a form of ax squared plus bx plus c equal to 0. You can divide the entire equation by a to get its equivalent equation, which is x squared plus b over ax plus c over a, which is equal to 0, which is an equation of the form of x squared plus bx plus c is equal to 0. And then the key is in factoring. So you can write x squared plus bx plus c as x minus alpha multiplied by x minus beta, which is x squared minus alpha plus beta x plus alpha multiplied by beta. Now you get that alpha plus beta is equal to negative b and that alpha multiplied by beta is equal to c. If you can find alpha and beta such that this works, then they are all the solutions. Now this particular relationship between the sum and the product of the two solutions of a quadratic equation and the coefficients is called Viète's relations, and that was known in mathematics hundreds of years ago, since Viète was a Renaissance era mathematician. So by doing this, we have also provided a proof for Viète's relations for quadratics. So there is a relationship here between this method and Viète's relations. This method establishes Viète's relations. The second trick which we have used is the trick of saying if I have to find the two numbers with a given sum and a product. This was actually done thousands of years ago by the Babylonians. The Babylonians knew that if you wanted to solve these problems, the easiest way would be to go from the average plus or minus a certain amount. So this particular method is just a combination of two insights that have been known for hundreds of years and for thousands of years. That is what makes it even more surprising that this method hasn't been the one that we all learn in school. Please like, share, subscribe, and leave a comment. If you want to see another approach to solving a quadratic equation, I suggest that you watch this video next. So thank you for watching, and I'll see you in the next video.